Okay, now we need to look at how to do a quadratic regression. For the homework that's due tomorrow, you're going to need to know how to do this. But if you come in and you've created a table, so let's assume you've already done that. So whatever table you're working with, you've already put in, right? You can see that the points get plotted like usual. I purposefully made it so that a quadratic regression won't fit perfectly, but it should be pretty close. Now, in the calculator, if you're using that, when you go to second calc, before you would do the lin reg for a linear regression, now you put in your list 1, list 2, and then you're going to go into that calculate list, and it's going to be QuadReg for quadratic regression. So calculator, pretty straightforward. In Desmos, right, for a linear regression, we would do mx plus b, because that's a form of a line, right? So you can see that mx plus b, a linear regression, has an r² of 0.939, so not too bad. If we want to do quadratic regression, it's ax squared plus bx plus c. So standard form of a quadratic equation, ax squared plus bx plus c. You just need to remember that instead of just x, you're putting in this x1. Since it's a regression, there's a little squiggle. So for the most part, it's the same idea as a linear regression. You're just typing in the standard form of a quadratic equation as opposed to a slope-intercept form of a linear equation. You can see the r², it fits very, very well, 0.99. And just like with the linear, where it would tell you what m and b are, here tells you a is 0.702, b is 0.893, c is 4.762. So that's how you do a quadratic regression, and you would use the r² to compare a linear to a quadratic model.